from Sun University campus Larkana, Department of Computer Science. And today we discuss four topics of Calculus and Analytical Geometry of 3D Engineering.
Outline: what is a function, domain and range, limits involving infinity and continuous function, derivatives. First of all, we discuss what is a function. A function is defined as a relation between a set of inputs having one output each. In simple words, a function is a relationship between inputs where each input is related to exactly one output. Every function has a domain and codomain or range. A function is generally denoted by f of x, where x is the input. The general relationship between a function is y equal to f of x. Types of functions. An example of simple functions is f of x equal to x square. In this function, the function f of x takes the value of x and then squares it. For instance, if x equal to 3, then f 3 equal to 9. A few more examples of function are f of x equal to sin x, f of x equal to x plus 3, f of x equal to 1x, f of x equal to 2x plus 3, etc. There are several types of functions in maths. Some of the important types are injective function or one-to-one function. When there is a mapping for a range for each domain between two sets. Surjective functions are onto function when there is a more than one element mapped from domain to range. Polynomial function, the function which consists of polynomials. Inverse function, the function which can inverse another function. These are a few examples of functions. It should be noted that there are various other functions like into function, algebraic function, etc. Learn here all the functions. One-to-one functions, onto function, polynomial function, inverse function. Definition of one-to-one function. A function has many types, and one of the most common function used is the one-to-one function or injective function. Also, we will be learning here the inverse of this function. One-to-one function defines that each element of one set, says set A, is mapped with a unique element of another set, says set B. Onto function. Onto function could be explained by considering two sets, set A and set B, which consist of elements. If for every element of B there is at least one or more than one element matching with A, then the function is said to be onto function or surjective function. The term for the surjective function was introduced by Nichols Bourbaki. Polynomial function. A polynomial function has only positive integers as exponents. We can even form different types of arithmetic operations for such functions like addition, subtraction, multiplication and division. Some of the examples of polynomial functions are here. X square plus 2x plus 1 equals 0, 3x minus 7 equals 2, 7x square plus x square minus 2 equals 0. All three expressions above are polynomial signs. All of the variables have positive integer exponents, but expressions like 5x square plus 1 equal to 0, 4x square plus 3x plus 1, 9x plus 1 division x are not polynomial equations. We cannot consider negative integers exponents or fraction exponents or division here. Inverse function. An inverse function or an anti-function is defined as a function which can reverse into another function. In simple words, if any function f takes x to y, then the inverse of f square will take y to x. Examples. Second is domain and range. Domain, the set of all possible values which qualify as an input to a function, is known as the domain of the function, or it can also be defined as the entire set of values possible for independent variables. Domain can be found if the denominator of the fraction is not equal to 0 and the digit under the square root bracket is positive. In case of a function with fraction values, for the domain of the function f is set A, India, Pakistan, Australia, Sri Lanka. How to find the domain of function? To find the domain, we need to look at the values of the independent variables which are allowed to use as explained above. Non-zero at the bottom of fraction and no negative sign in square bracket. Range, the set of all the output of a fraction is known as the range of the function x, or after substituting the domain, the entire set of all values possible as outcomes of the dependent variable y. For the range of the function f is 1983, 1987, 1992, 1996. On the other hand, the whole set B is known as the codomain of the function. It is the set which contains all the outputs of the function. So the set of real numbers is a codomain for every real valued function. The codomain of the function f is set B. How to find the range of a function? The separate of all the y values from minimum to maximum is the range of the function. In the given expression of y, substitute all the values of x to check whether it is a positive, negative, or equal to other values. Find the minimum and maximum values for y. Then draw a graph for the same. Third is limits involving infinity and continuous function. Limits and continuity concept is one of the most circular topic in calculus. Both concepts have been widely explained in class 11 and class 12. A limit is defined as a number approached by the function as an independent function's variable approaches a practical value. For instance, for a function f of x equal to 4x, you can say that the limit of f of x as a x approach to is 8. To be symbolic, it is written as a limit x approach to 4x equal to 4 multiplied 2 equal to 8. Continuity is another widespread topic in calculus. The easy method to test for the continuity of function is to examine whether the graph of function can be traced by a pen without lifting the pen from the paper. When you are doing with pre-calculus and calculus, a conceptual definition is almost sufficient, but for higher level a technical definition is required. You can learn a better and precise way of defining continuity by using limit. Continuity. A function is said to be a continuous at a particular point if the following three conditions are satisfied. First, f of a is defined. Second, limit x tends to a f of x exists. Third, limit x tends to a plus f of x equal to limit x tends to a minus f of x equal to f of a. A function is said to be a continuous if you can trace its graph without lifting the pen from the paper, but a function is said to be discontinuous when it has any gap in between. Let us see the type of discontinuities. Types of discontinuity. There are basically two types of discontinuity: infinite discontinuity, jump discontinuity. Infinite discontinuity, a branch of discontinuity where a vertical asymptote is present at x equal to a and f of a is not defined. This is also called as asymptotic discontinuities. If a function has values on both sides of an asymptote when it cannot be connected, so it is discontinuous at the asymptote. Jump discontinuity. A branch of discontinuity wherein a limit x tends to a plus f of x nautical limit x tends to minus f of x, but both the limits are infinite. This is also called a simple discontinuity or continuities of first kind. Positive discontinuity. A branch of discontinuity wherein a function has a predefined two-sided limit at x equal to a, but either f of x is undefined at a or it is a value is not equal to the limit at a.
Fourth and last, derivatives. Derivatives are defined as the varying rate of change of a function with respect to an independent variable. The derivative is primarily used when there is some varying quantity and the rate of change is not constant. The derivative is used to measure the sensitivity of one variable, dependent variable, with respect to another variable, independent variable. Derivative meaning. Derivative math refers to the instantaneous rate of change of a quantity with respect to the other. It helps to investigate the moment by moment nature of amount. Derivative example. Let a car takes t second to move from a point A to point B. But how long will it take to move from point A to C? Or how much distance will it cover in t minus 1 seconds? This can be known from the velocity, that is as follows. Velocity v equal to dx upon dt, where x is the distance traveled and t is the time taken to cover that distance. This will give you the distance covered per unit time, so that we can analyze any distance covered in any travel of time. Derivatives math calculus. The process of finding the derivatives is called differentiation. The inverse process is called anti-differentiation. Let the derivatives of function be y equal f of x. It is the measure of the rate at which the value of y changes with respect to the change of the variable x. It is known as the derivative of function f with respect to the variable x. If an infinitesimal change in x is denoted as dx, then the derivative of y with respect to x is written as a dy upon dx. Here the derivative of y with respect to x is read as dy by dx or dy over dx. Example. Let y be a dependent variable and x be independent variable. Let there be a change in the value of x, that is dx. This change in x will bring a change in y, let that be dy. Now to find out the change in y with the unit change in x can be found as follows. Let f of x be a function whose value varies as the value of x varies. Step to find the derivative. Change x by the smallest possible value and let that be h, and so the function becomes f of x plus h. Get the change in value of function, that is f of x plus h minus f of x. The rate of change in function f of x on changing from x to x plus h will be dy dx equal f of x plus h minus f of x h. Now dx is ignorable because it is considered to be too small. First order derivatives. The first order derivatives tell about the direction of the function, whether the function is increasing or decreasing. The first derivative method or first order derivative can be interpreted as instantaneous rate of change. It can also be predicated from the slope of the tangent line. Second order derivative. The second order derivative are used to get an idea of the shape of the graph for the given function. The function can be classified in terms of concavity. The concavity of the given graph function is classified in two types, namely concave up, concave down. Calculus derivative example. Let f of x be a function where f of x equal to x square. The derivative of x square is 2x, means that with every unit change in x, the value of the function becomes twice 2x. Limits and derivatives. When dx is made so small that it is becoming almost nothing. With limits, we mean to say that x approaches 0 but does not become 0. Mathematically means for all real epsilon greater than 0, there exists a real omega greater than 0, such that for all x with 0 less than x minus c less than omega, we have f of x minus l less than epsilon. Key concepts. To differentiate a power of x that is in the denominator, first express it as a power with a negative exponent, e.g. 1 multiplied 2 equal to x minus 2. Derivative rules simplify the process of differentiating polynomial function. To differentiate a radical, first express it as a power with a rational exponents. Apply derivative rules to solve an instantaneous 3 years rate of change problem. A skydiver jumped out of a plane from a height of 2,200 meters. The skydiver's height above the ground in meters after 3 seconds is represented by the function ht equal to 2,200 minus 4.9 t square. Assuming air resistance is not a factor, how fast is the skydiver falling after force? Solution. The instantaneous rate of change of the height of the skydiver at any point in time is separated by the derivative of the height function. ht equal to 2200 minus 4.9 t square. ht equal to 0 minus 4.9 2t equal to minus 9.8 t. Substitute t equal to 4 into the derivative function to find the instantaneous rate of change at 4s. ht equal to minus 9.8, 4 equal to minus 39.2. Thanks.